NFPA 79, the electrical standard for industrial machinery, addresses the use of appliance wiring material, or AWM cables. AWM cables are generally not permitted as a wiring method for industrial machinery unless they are part of a listed assembly. A listed assembly is a complete unit that has been tested and approved by a nationally recognized testing laboratory, or NRTL. This assembly includes all necessary components like the wires, cables, connectors, and enclosure. The restriction on AWM cables stems from the fact that they are typically designed for internal wiring of appliances. They may not be suitable for the harsh industrial environments often encountered by machinery. Industrial settings often subject cables to mechanical stresses, extreme environmental conditions, and hazardous materials. Using AWM cables in these environments could lead to several negative consequences. Firstly, they could pose a fire hazard due to overheating or improper insulation. Secondly, they could cause electrical faults or failures. Thirdly, they could compromise the safety of personnel and equipment. And fourthly, they could violate NFPA 79 code requirements. As alternatives to AWM cables, consider using cables that are listed as extra hard usage or machine tool wire. Cables compliant with UL 1072 or UL 1078 are also suitable. Always ensure that the cables are approved by an NRTL for the specific application. The selected cable should be appropriate for the voltage, current, temperature, and environmental conditions involved. To summarize, AWM cables should not be used on industrial machinery unless they are part of a listed assembly. Using them outside of this context violates NFPA 79 code requirements and creates safety hazards. It is therefore essential to use approved cables specifically designed for the industrial application to ensure both safety and code compliance. When selecting cables for industrial machinery, several factors must be considered to ensure safety and compliance with NFPA 79. One key aspect is the voltage rating. A cable must be rated for the maximum voltage that it will be exposed to in the application. Using a cable with an insufficient voltage rating can lead to insulation breakdown and electrical hazards. Another crucial factor is the current carrying capacity, often referred to as ampacity. The cable's ampacity must be sufficient to handle the maximum current that will flow through it. Overloading a cable can cause it to overheat, potentially leading to a fire. Temperature ratings are also important, particularly in industrial environments where machinery can generate significant heat. Cables must be able to withstand the expected operating temperatures without degrading or becoming brittle. The environmental conditions in the industrial setting also play a role in cable selection. Cables may need to be resistant to moisture, chemicals, oil, abrasion, and other factors that could compromise their integrity. Consider using cables with appropriate shielding or jacketing to protect them from these environmental factors. The mechanical stresses that cables will be subjected to should also be taken into account. Cables may need to withstand bending, twisting, pulling, and vibration. Flexible cables with appropriate strain relief mechanisms are often necessary in these situations. In addition to these factors, it's also important to consider the specific requirements of the application. For example, some applications may require cables with specific flame retardant properties or resistance to electromagnetic interference, or EMI. When selecting cables, always consult the manufacturer's specifications and any relevant industry standards to ensure that the cable is suitable for the intended application. Remember that using the wrong type of cable can have serious consequences, including electrical failures, fires, and injuries. Listed assemblies, as mentioned earlier, are pre-engineered and tested systems that include all necessary components for specific application. These assemblies are typically certified by an NRTL and provide a convenient and reliable way to ensure that all components are compatible and meet the required safety standards. When using a listed assembly, carefully follow the manufacturer's instructions for installation and use. Do not modify the assembly in any way, as this could void the certification and create a safety hazard. If you are unsure about any aspect of cable selection or installation, consult with a qualified electrical engineer or inspector. They can help you assess the specific requirements of your application and ensure that you are using the correct cables and installation methods. Proper cable selection and installation are essential for ensuring the safety and reliability of industrial machinery. By carefully considering the factors discussed above and following all applicable codes and standards, you can minimize the risk of electrical hazards and protect personnel and equipment. Now let's talk more specifically about the alternatives to AWM cables mentioned earlier, namely extra hard usage cables and machine tool wire. Extra hard usage cables are designed for use in demanding industrial environments where they will be subjected to frequent movement, flexing, and abrasion. These cables typically have a durable outer jacket that provides excellent resistance to oil, chemicals, and abrasion. They also often have stranded conductors for increased flexibility and resistance to fatigue. Machine tool wire, or MTW, is another type of cable commonly used in industrial machinery. MTW is a single conductor wire that is typically used for internal wiring of machine tools and control panels. It is designed to be flexible and resistant to oil, chemicals, and abrasion. MTW is typically rated for 600 volts and 90 degrees Celsius. When using extra hard usage cables or MTW, be sure to select the appropriate gauge for the application. The gauge of the wire determines its current carrying capacity. Using a wire that is too small for the application can cause it to overheat and potentially start a fire. Also, ensure that the cables are properly supported and protected from damage. Cables that are not properly supported can be subjected to excessive stress, which can lead to insulation breakdown and electrical hazards. Furthermore, make sure the cables are protected from sharp edges, abrasion, and other potential sources of damage. Using conduit or other protective measures can help to extend the life of the cables and prevent electrical hazards. Consider using appropriate strain relief connectors at cable entry points to prevent the conductors from being pulled out of their terminals. Strain relief connectors also help to protect the cables from damage caused by bending and twisting. Regularly inspect cables for signs of wear and tear. Look for cracks, abrasions, and other damage to the insulation. If you find any damage, replace the cable immediately. Damaged cables can pose a serious electrical hazard. Proper grounding is also essential for the safety of industrial machinery. Grounding provides a path for fault current to flow back to the source, which helps to protect personnel from electric shock. Make sure that all equipment is properly grounded in accordance with applicable codes and standards. Use appropriate grounding conductors and connectors. Regularly inspect grounding connections to ensure that they are tight and free from corrosion. In addition to the above, consider using surge protection devices to protect sensitive electronic equipment from voltage spikes and surges. Voltage surges can damage electronic components and cause equipment failures. Surge protection devices can help to mitigate these risks. Follow all applicable codes and standards when installing and maintaining electrical equipment in industrial machinery. These codes and standards are designed to ensure the safety of personnel and equipment. Consult with a qualified electrical engineer or inspector if you have any questions about electrical safety or compliance. They can provide guidance on proper cable selection, installation, and maintenance practices. Regularly train personnel on electrical safety procedures. Training can help to prevent accidents and injuries. Ensure that personnel are aware of the hazards associated with electricity and the proper procedures for working with electrical equipment. Provide training on lockout-tagout procedures to prevent accidental energization of equipment during maintenance or repair. Lockout-tagout procedures ensure that equipment is energized and locked out before any work is performed. Use appropriate personal protective equipment, or PPE, when working with electrical equipment. PPE can help to protect personnel from electric shock, burns, and other injuries. Common types of PPE include safety glasses, gloves, and insulated tools. Always inspect PPE before use to ensure that it is in good condition. Remember that electrical safety is an ongoing process. It requires a commitment to following safe work practices and staying up to date on the latest codes and standards. By taking these precautions, you can help to ensure the safety of personnel and equipment in industrial settings. Choosing the right cable for an industrial application extends beyond basic voltage and amperage requirements. You must also consider the specific environment and potential hazards that the cable will be exposed to. For instance, if the machinery operates in an area with high levels of oil or chemicals, you'll need cables with jackets specifically designed to resist these substances. Common jacket materials for chemical resistance include chlorosulfonated polyethylene, or CSP, and fluoropolymers. Abrasion resistance is another crucial factor, especially in environments where cables might rub against machinery or other surfaces. Cables with tough polyurethane jackets are often chosen for their superior abrasion resistance. Temperature extremes can also significantly impact cable performance. High-temperature environments require cables with insulation and jacket materials that can withstand the heat without degrading. Silicone, rubber, and fluoropolymers are commonly used in high-temperature cables. Conversely, low-temperature environments can cause some cable materials to become brittle and crack. Cables designed for low-temperature applications use specialized polymers that remain flexible even in extreme cold. Flexibility is paramount in applications where cables are constantly moving or bending. Highly flexible cables utilize finely stranded conductors and specialized insulation materials to withstand repeated flexing without fatigue or damage. Shielding is essential in environments with electromagnetic interference, or EMI. Shielded cables use a metallic layer, often made of braided copper or aluminum foil, to block EMI from interfering with signal transmission. The choice of shielding depends on the frequency and intensity of the EMI. Approvals and certifications also play a critical role in cable selection. UL, or Underwriters Laboratories, is a widely recognized safety certification organization. UL-listed cables have been tested and certified to meet specific safety standards. CSA, or Canadian Standards Association, is another important certification body, particularly for equipment being used in Canada. CE marking indicates that a product complies with European Union safety, health, and environmental protection requirements. RoHS, or Restriction of Hazardous Substances, compliance ensures that a cable does not contain certain hazardous materials such as lead, mercury, and cadmium. REACH, or Registration, Evaluation, Authorization and Restriction of Chemicals, is a European Union regulation concerning the safe use of chemicals. Cables compliant with REACH regulations meet strict standards for chemical content. NEMA, or National Electrical Manufacturers Association, standards provide guidelines for cable construction, performance, and safety. Following NEMA standards ensures that cables meet industry best practices. When selecting cables, consider the installation environment and potential hazards. For example, cables installed in wet locations must be rated for wet environments. Cables buried underground must be designed for direct burial applications. Cables installed in hazardous locations, such as those with explosive gases or dust, must be intrinsically safe or explosion-proof. Consider the cable's bend radius. The bend radius is the minimum radius that a cable can be bent without causing damage. Exceeding the bend radius can damage the conductors or insulation, leading to electrical failures. Use cable trays or conduits to support and protect cables. Cable trays and conduits provide a safe and organized way to route cables. They also protect cables from physical damage, such as abrasion and impact. Label cables clearly and accurately. Labeling makes it easier to identify cables and troubleshoot problems. Use durable labels that will withstand the environmental conditions. Keep cable runs as short as possible. Shorter cable runs reduce voltage drop and improve signal quality. Avoid running cables near sources of heat or EMI. Heat and EMI can degrade cable performance and shorten its lifespan. When connecting cables, use the correct connectors and terminals. Incorrect connectors and terminals can cause loose connections, overheating, and electrical failures. Tighten connections securely. Loose connections can cause arcing, overheating, and electrical fires. Use a torque wrench to tighten connections to the manufacturer's specifications. Inspect cables regularly for signs of damage. Look for cracks, abrasions, and discoloration. Replace damaged cables immediately. Keep cable records up to date. Cable records should include information about the cable type, size, length, and location. This information is helpful for troubleshooting and maintenance. Proper cable management is essential for ensuring the safety and reliability of electrical systems. By following these guidelines, you can minimize the risk of electrical hazards and extend the life of your cables. Think about the long-term cost of cable failures. Investing in high-quality cables and proper installation practices can save money in the long run by reducing downtime and maintenance costs. Stay informed about the latest codes and standards. Electrical codes and standards are constantly evolving. Staying informed about the latest changes can help you ensure that your electrical systems are safe and compliant. Consider using a cable management software program. Cable management software can help you track cable inventory, schedule maintenance, and generate reports. This can improve efficiency and reduce errors. The semiconductor industry relies heavily on specialized equipment with intricate wiring systems. When selecting cables for this industry, several unique considerations come into play. Cleanliness is paramount. Semiconductor manufacturing environments are extremely sensitive to contamination. Cables used in these environments must be free of particles and outgassing materials that could compromise the purity of the manufacturing process. Cables with low outgassing properties, such as those made with fluoropolymers, are often preferred. Chemical resistance is also critical. Semiconductor manufacturing processes involve a wide range of harsh chemicals. Cables must be able to withstand exposure to these chemicals without degrading or releasing contaminants. Cables with chemically resistant jackets, such as those made with PTFE or PFA, are commonly used. Precision and reliability are essential. Semiconductor manufacturing equipment requires precise control and reliable operation. Cables used in these systems must provide stable electrical performance and be resistant to interference. Shielded cables with low capacitance are often used to minimize signal distortion and ensure accurate data transmission. Space constraints are often a factor. Semiconductor manufacturing equipment is often densely packed, with limited space for wiring. Cables must be flexible and compact to fit into tight spaces. Small diameter cables with tight bend radii are often preferred. Temperature control is also important. Semiconductor manufacturing processes often involve extreme temperatures. Cables must be able to withstand these temperatures without degrading or affecting performance. Cables with high temperature insulation, such as those made with silicone rubber or fluoropolymers, are commonly used. Static dissipation is crucial. Static electricity can damage sensitive electronic components. Cables used in semiconductor manufacturing environments must be designed to dissipate static charges. Cables with conductive or dissipative jackets are often used to prevent static buildup. Vacuum compatibility is often required. Some semiconductor manufacturing processes are performed in vacuum environments. Cables used in these environments must be compatible with vacuum conditions. Cables with low outgassing properties and sealed connectors are often used to prevent vacuum leaks. Traceability is essential. Semiconductor manufacturers often require detailed traceability of all components used in their equipment. Cables must be labeled with the manufacturer's name, part number, and date code to ensure traceability. Compliance with industry standards is critical. Cables used in semiconductor manufacturing equipment must comply with relevant industry standards, such as semi-standards. Semi-standards provide guidelines for equipment safety, performance, and reliability. Working with a reputable cable supplier with experience in the semiconductor industry is essential. A knowledgeable supplier can help you select the appropriate cables for your specific application and ensure compliance with all relevant requirements. Consider the long-term cost of cable failures. In the semiconductor industry, even a short period of downtime can be extremely costly. Investing in high-quality cables and proper installation practices can save money in the long run by reducing downtime and maintenance costs. Stay up to date on the latest technologies and trends in the semiconductor industry. The semiconductor industry is constantly evolving. Staying informed about the latest technologies and trends can help you make informed decisions about cable selection and installation. Cables form the crucial nervous system of any industrial machine. Selecting the right cable is not merely about fulfilling a functional requirement, it's about ensuring safety, reliability, and longevity. The initial cost savings from using cheaper, non-compliant cables can be quickly offset by the cost of downtime, repairs, and potential safety hazards. Prioritize cables that are certified by recognized testing laboratories like UL or CSA. These certifications indicate that the cable has been rigorously tested and meets stringent safety standards. Don't compromise on quality when it comes to cable selection. Always choose cables that are designed for the specific application and environment in which they will be used. Remember, the cables you choose today will determine the performance and reliability of your industrial machinery for years to come.